first.
Yeah.
Yes. Always, always, no matter what problem I give you, you check for a greatest common factor. So let's practice that. Okay, notice I'm just asking you to factor. This isn't an equation. I'm not asking you to solve for x. We are just factoring these. And I just asked for the greatest common factor here. So you're not even worrying about box method or anything yet. What is the greatest common factor? 2. When you factor it out, what happens to it? Where does it go?
The outside of parentheses.
Okay, so factoring something out is like dividing. So when I pull that out, we have x squared minus 2x plus 4. We essentially just divide each of those things by 2. Is that okay so far? So you have to look at those two terms. Looking at my numbers, my coefficients, what can we take out? With the variables, you pull out the smallest exponent, so 6a squared. Now if you take out something entirely, we'll put a 1. If you divide a number by itself, it gives you 1. 18 divided by 6 is 3. You had 4 a's, you took out 2 of them, so there's 2 left. A few more. What do you think we're going to take out this time? We can take out x squared. We can take out a y squared, and for the coefficients, they're all divisible by 7. Okay, so what am I left with?
2x minus 4y plus 3.
How can you check yourself on a factoring problem?
Just plug it in.
Just multiply it out and see if you get what we started with. All right, I'm going to put a couple more up that are a little bit different but the same idea. We kind of get in this mindset when we're looking at greatest common factor that it has to be just a single number or a variable that we're pulling out. If I look at this, a little bit uglier, how many terms do we have?
3.
This is a term. This is a term, and this is a term. Looking at my coefficients, 24, 16, and 6. They are all divisible by?
16 isn't divisible.
Yes, 16 is divisible by 3, so we have to go 2. Okay, what else do all of these have?
X squared.
X minus 2. I'm going to take out 2 and x minus 2. I'm going to put a bracket next. It doesn't matter, bracket's just like a parenthesis, it's just a little prettier to look at. So 24 divided by 2 is 12. We had 3 of these, I took out 1, so there are 2 left. $16 divided by 2 is 8. We had an x minus 2 squared, I took out 1 of them. So we have an x minus 2 left. 6 divided by 2 is 3. We took out that x minus 2. So that's it. Now, could we start multiplying all that out and adding my terms? Yeah. But I didn't tell you to do that. I just asked you to factor it. I asked you to pull out the greatest common factor, so we're done there. Let's try one more like that. This is a little bit different than you're probably used to. What if I said terms do we have?
Two.
Two. Okay. Each of these terms has two parentheses. What do they have in common?
1 plus 1.
So if I take out the y plus 1. So in the first one, if I take out the y plus 1, you're left with minus. In the second one, if I took out the y plus 1, we have let's go ahead and finish simplifying this one. You know, the last one had a square, it was a little bit uglier, but this one's not too bad. What would we need to do?
Just subtract like that.
Yeah, if you distribute this negative, so 5y and negative y would be 4y. 3 plus 1 is 4. Anything else we could do?
You can solve for y, subtract them.
I don't want to.
You can take out the next thing. You can take out a y.
Look at that parentheses.
Because
Yeah, it has the greatest common factor. We could take a 4 out of it. And if I take a 4 out of that, you're left with
y
plus 1. So you can write it like this. What's the other way you could write
plus
that?
4y plus 1 squared.
Then. Alright, so I put this one up here intentionally just to kind of show you, always make sure you can't factor any further. Okay, we got here, but we still have the greatest common factor. So always factor it down as far as you can. Alright. Do you guys remember difference of squares? Maybe, let's see.
Oh yeah, oh yeah.
So still look for the greatest common factor. And we might have one on these still. We don't here. If you remember difference of squares, you have to have a subtraction here, and they both have to be perfect squares. And then what happens is it factors into two identical parentheses. One of them has a positive and one has a negative. So y squared, or x squared would break into x and x. What's the square root of 4?
2.
So x plus 2, x minus 2. Does it matter if you write x minus 2, x plus 2?
No.
No. That's all we need. Quick check, if you multiply this all out, you get back to the x squared minus
I totally tried to get along with the square roots there.
2. Oh. Getting too fancy here. Sorry. What would this be? Because they're both perfect squares, no subtraction. Square root of 16 is 4, x squared breaks into an x, square root of 1 is 1. So same idea. X to the 4th. If you want to split that up, each parenthesis has to do the same thing. So what would each one get? X squared. If you have 4 x's, then each of them gets 2. And the square root of 16 is 4.
You can solve it.
Yes, we aren't done. X squared plus 4, can I do anything with that?
No.
No, because it's got a plus. But x squared minus 4, those are both perfect squares and it's still a subtraction. So that one can break down again. X squared would break into x. We need a plus and a minus. Square root of 4 is 2.
Oh, yeah.
So is there a greatest common factor? No. 9x to the 4th, that's a perfect square. 4 is a perfect square, but it's not subtraction. So if something doesn't factor, what's the word for it?
Wrong.
Prime.
Prime.
Oh.
If we can't factor at all, we call it prime. Okay, so we've done GCF and difference of squares. So far, so good? I want to look at one more type today, and then that'll probably be as far as we get. Let's talk about trinomials a bit. Now, you guys are going to have to be a little bit patient, because I know Mrs. Keller taught it some different ways last year. So I'm going to try to make sure I say things the same way she does. Okay, so if I say something and that's not what she said, tell me and I'll try to talk about it the way she did. Because I think she did slip and slide method last year.
Yes.
Okay, so we are going to do that. Now, on a trinomial, you don't always have to do slip and slide. When do you need that?
Whenever it is.
When A doesn't equal.
If that squared term in the front is not a 1x squared, that's when we need slip and slide. So let's start out with some nicer ones. If I do just have a 1x squared, you don't really have to do anything too fancy. You can just factor it. Always first check for that greatest common factor, and there isn't one. So it will factor into two parentheses. X squared breaks into x. Then I need two numbers that multiply to 8 and add to positive 6.
Or 2.
Positive 4, positive 2. 4 times 2 is 8, 4 plus 2 is 6. Why don't you guys try it? Okay, something I'm going to say about factoring, it's one of those things that some people it's really easy for and some people it's hard for. So if it's difficult for you, don't get frustrated. Come see me if we need to look at different methods. I've got lots of different ways. I don't want to confuse you by going over 6 different ways in class, but if what I'm doing doesn't make sense, tell me and I can show you other options. So we know x squared breaks into x. If they multiply to a negative, the only way to get a negative is if you take a positive, well, I don't know why I put my x back there. A positive times a negative, right? And they have to add to positive 3. So things that multiply to 18. 1 and 18, 2 and 9, 3 and 6. If we want a positive 3, the bigger number needs to be positive, so x plus 6, x minus 3. 6 plus negative 3 is 3, positive 6 times negative 3 is negative 18. So it works. Yeah. X and x. Multiply to positive 40, so I know my signs have to be the same. They have to add to positive 13, so we need 2 positives. So things that multiply to 40, 1 and 40, 2 and 20, 4 and 10, 8 and 5, and 8 plus 5 is 13.
That's the winner.
Facts.
Okay. multiply to a negative 14, so that means we have to have a positive and a negative. Add to negative 5. Negative 7, positive 2. Since the 5 is negative, my bigger number has to be negative. 2 times negative 7 is negative 14. 2 plus negative 7 is negative 5. Okay, I know some of us still probably need more practice with this just because maybe it's not as quick thinking of those math facts and that number reasoning, and that's okay. Do you remember doing this?
Yeah.
Okay.
Just like-
Let's say.
Because when the class taking it down, 3,000 problems.
3,000 problems. Is that what they say I give every day?
50 million problems.
It was good until Miss Heather started like being like, she'd give us like 20 problems, and then she'd be like, okay, we're gonna grade it at the end of class, and we had 10 minutes left, and we're all like, grade? Excuse me?
Pressure's on. Okay, so you guys have to bear with me this time. So she did the slip and slide, and I haven't taught that way before, but we're gonna try, okay? So why do I need the slip and slide here?
Because A is not equal to 1.
This isn't a 1, so we need the slip and slide. So what she did is she brought this 2 down here. So we kept the x squared, we kept the 5x, and then you did 2 times
Yeah, multiply.
negative 3. So that's negative 6. Now this is like the problems we just got done doing. So x squared would break into 2 parentheses. They need to multiply to a negative 6 and add to a positive 5.
6 and negative 1.
Okay. But remember, we started out by bringing that 2 over, so
By 2.
we have to bring it back. So we divide by 2. Okay, so 6 divided by 2 is 3. Okay, you can't do 1 divided by 2.
2x minus 1.
Yeah, so if you can't divide it, the 2 comes back.
Yes, sir.
And we can check it if we FOIL. So we get 2x squared minus x plus 6x, which is 5, minus 3. So it works out.
Do you think it's less time consuming?
It's a toss-up, really. Depending on how much work you show on the box method, it might be a little bit faster. If you don't write out everything on the box method, they're probably equivalent. Yeah. Does it make sense?
Yeah, I just had to like, my biggest problem is forgetting to divide.
Yes. And that is the biggest issue with this, is forgetting about that 2 that you brought down.
I don't like how your marker thing
Oh, but I know.
randomly.
Yeah, well, because if I use these pre-selected, the size is already determined, but I always think that's too bad if I go in and change it.
I wish there was a way to like auto,
Yeah.
make it, so you see.
Need
All of
to.
this reading, all of this.
Yeah.
Okay, let's look at this one. You boys are getting distracted.
I don't know what you're talking about.
Focused.
So your attention span is about 30 minutes for each direction. Before we get distracted.
Yeah. Talking about last way.
So what would I do here?
I think I was doing.
Yes, there is a greatest common factor.
Oh,
Don't
so
forget to look for that.
Such a silly use of me.
So if we factor out that 2,
Square plus 6 plus 8. Or 6x.
okay, now we can do box method with, or not box method, the shortcut here.
Easy method.
Easy method, yes. Okay, so what would multiply to 9 and add to 6?
So we would just write it as 2x plus 3 squared.
Yes, I will take it either way. They are equivalent, so however you would like to write that. We don't have to solve them since there's no equal. We will eventually. We just don't have to do that yet.
I'm not talking about it. I'm just trying to.
Do we have Gray's common factor? No. So what do we have to do? Slip and slide. So I have to look at this 9, and I'm going to bring it over. So that will make it x squared minus 6x, 9 times 1 is 9. So what multiplies to 9 and adds to negative 6? But don't forget about your 9. So we need to divide by 9. It doesn't work. So what do we do here? We don't just bring the 9 in front.
Simplify it.
Simplify it.
3x minus
3 over 9 turns into 1/3, so you bring the 3 in front. So 3x minus 1. Same thing here. 3 over 9 is 1/3, so you bring that 3 back in front. 3x minus 1. Yeah, you can also write this 3x minus 1. Okay, I am quite certain that I'm probably not like drawing the same arrows Mrs. Keller did or necessarily showing it the exact same way she did. Is it clicking? Do I need to write or say something differently to make connect the dots? Okay. All right. Let's stop here. So here's what we're going to do. We're probably not experts at these trinomials yet, and that's okay because we're going to keep working on it. Everybody has a Chromebook now, right? And everyone's in Classroom. So I posted a handout on Classroom, but I don't think we're ready for all of it. How much time do we have?
13 minutes.
All right. What do you think? 1 through
You're so funny.
12?
You're a dog.
Oh.
Can we do 1 through 12? Seem reasonable?
Is it done in the class?
No.
Yep.
Oh.
Okay, so handout, just do 1 through 12 for now.